Assalamualaikum and hi everyone. This video will discuss section 5.2 solving inequalities in subject SMU3013. An equality is a statement that two quantities or expressions are not equal. For example, 2x plus 3 greater than 11. The left-hand side is greater than 11. If a true statement is obtained when a number is substituted for x, then that number is a solution of the inequality. For instance, x equals to 5 is a solution of 2x plus 3 greater than 11. How? We try to substitute x equals to 5 into the left-hand side, and we get 13. And we know that 13 is greater than 11. X equals to 5 makes this inequality true. However, if we substitute x equals to 3 into this inequality, the left-hand side becomes 9. And 9 is not greater than 11. X equal to 3 is considered as not a solution to this inequality. Section 5.2.1 is about properties of inequalities. We already discussed these properties in chapter 2. Okay, I just want to stress here, if we multiply or divide both sides of an equality by a negative real number, it will reverse the inequality sign. Okay, let's discuss example 5.20. Solve the inequality negative 3x plus 4 less than 11. We are given this inequality. So how to simplify the given inequality is we need to remain only variable on the left hand side. Therefore, we need to eliminate 4 from the left hand side. To eliminate 4 from left hand side, we need to subtract 4 from both sides. So now the left hand side becomes negative 3x and the right hand side is 7. 7 comes from 11 minus 4. Now we only need to make sure the coefficient of x is 1. To obtain coefficient 1, we divide both sides by negative 3. Since we divide both sides by negative, we need to reverse the inequality sign. Okay, so we get negative 3x divided by 3 and 7 divided by negative 3. Negative 3. So we reverse the sign. From less than, it becomes greater than. So now we simplify. Negative 3 divided by negative 3 is positive 1. So we have x on the left hand side greater than negative 7 over 3. Okay, thus the solution of this the given inequality consists of all real numbers x such that x greater than negative 7 over 3. This can be written as the interval from negative 7 over 3 to infinity, or we can write as a set, where set x, where x greater than negative 7 over 3. Okay, let's move to the next example. Okay, now let's solve example 5.21. Okay, we have 4x minus 3 less than 2x plus 5. Okay, now let's group only variable on the left hand side and constant on the right hand side. Okay, for the variable, we have 4x. And then 2x need to be eliminated from the right hand side. So this one we minus 2x. Okay, we already write this one and this one. Okay, then the sign remain as less than. For the left right hand side, we have 5. Okay, and we need to eliminate negative 3 from the left hand side. So we need to add 3 both sides. So plus 3. Okay. So now we have grouped the variables on the left and constant on the right. Okay, now let's simplify. So we have 2x less than 8. And x less than, divide by 2 both sides. So we have 8 over 2. Simplify, we get x less than 4. Okay, hence the solution of the given inequality can be written as the interval from less than 4. So it starts from negative infinity until 4. Next, example 5.22. Solve the inequality of x squared plus 6x minus 7 greater than or equals to 0. We have quadratic inequality. So how to solve quadratic? Either by factorize the left hand side, or we use completing the square method, or quadratic formula. Okay, for this example, we can factorize this quadratic inequality. Okay, we have x squared plus 6x minus 7. We can factorize it as x plus 7 and x minus 1. Okay, and left hand side greater than or equal to 0. Okay, means that the left hand side always positive. Okay, solution of x plus 7 and x minus 1 equals to 0 are x plus 7 equals to 0 or x minus 1 equals to 0, which lead to x equals to negative 7 or x equals to 1. Okay, the table below helps to solve the quadratic inequality. We draw a table. We have x equals to negative 7. So here is x equals to negative 7 and x equals to 1. Okay, so we have 3 parts. One is all x that less than negative 7. And next, we have between negative 7 and 1. And this, the third part is x greater than 1. Okay, how to know that we need to include the number? Okay, from the sign of the inequality. Okay, this sign we have greater than or equals to. Means we need to include the solution. Okay, we need to include negative 7 and 1 as the solution to this inequality. Okay, so for number that less than negative 7, so it starts from negative infinity until negative 7, include negative 7. And then from negative 7 until 1, also include both numbers. And from 1 until infinity, also include 1. Okay, so we have 3 intervals. Okay, now let us assign any x that are within this interval. Okay, the first one, what x is less than or equal to negative 7? Okay, let's choose x equals to negative 8. Okay, now substitute this value into the left hand side. Okay, so we have negative 8 plus 7 times negative 8 minus 1. So we get negative 1 times negative 9, which is 9. Next, for the second interval, okay, we have we need to choose x between negative 7 to 1. Okay, the easiest one, we choose x equals to 0. Okay, substitute x equals to 0 into the left hand side. So we get 0 plus 7 times 0 minus 1. Okay, 7 times negative 1, it is negative 7. Okay, the last interval, we have from 1 until infinity. So let's choose x equals to 2. Okay, substitute 2 plus 7 and also 2 minus 1. So we have this one 9 times negative 1, which is 9. Okay, so which interval satisfies the inequality? Okay. We know that left hand side always positive, means we need to choose the interval that give all the result positive. So positive is this interval and also this interval. Okay, therefore the solution for this inequality is x, where x from negative infinity until negative 7, include negative 7, unite with 1 until infinity. Now let's move to example 5.23. Solve this inequality. 2x squared minus 3x minus 2 less than 0. Okay, now we also have a quadratic inequality. So how to solve this? Either by factorize this left hand side, or we use the quadratic formula. So can we factorize this? So we have two brackets, okay, less than 0. Okay, we have 2x on the first bracket and x on the second bracket. So 2 come from 1 times 2. Okay, and negative come from negative times positive. Okay, now, okay, where should we put 1 and 2? Okay, let's check. Okay, 2x times x is 2x squared. Okay, if we put 2 here and 1 here, okay, and the sign of 2 is negative, 1 is positive, so what can we get the same as the given inequality? Okay, so we have 2x times negative 2, which is negative 4x, and then plus x. So negative 4x plus x gives us negative 3. Therefore, we already choose the correct number to put in each bracket. Okay, after we factorize the left hand side, so what makes the left hand side equals to 0? Okay, the first bracket, from the first bracket, we have 2x plus 1 equals to 0 and x minus 2 equals to 0. So x is equal to negative 1 over 2 and x equals to 2. Okay, this is the border of the table. Okay, let's draw the table. We have how many columns? Okay, first column is for the left hand side, and then column for all x that less than negative 1 over 2, and then between negative 1 over 2 and 2, and then for x that all greater than 2. Okay, let's complete this table. Okay, we have x equals to negative 1 over 2 and x equals to 2. Okay. Here, this column is all x that less than negative 1 over 2. Okay, how do we know that we must to include negative 1 over 2 or not? It depends on the sign of the inequality. Okay, here we have sign less than or less than. Okay, means we cannot include 0. So this value, negative 1 over 2, give 0. Okay, give 0 to the left hand side. Okay, we want all value that less than 0. So we cannot include negative 1 over 2. So the first interval is from negative infinity until negative 1 over 2, not include. And then for the second column, we have negative 1 over 2 until 2, also not include. And the last one, for the third column, we have from 2 until infinity. Okay, now let's choose any x that satisfies every column. Okay, for the left hand side, we have 2x plus 1 times x minus 2. Okay, let's choose x within this interval. Okay, so let's choose x equals to negative 1. Okay, negative 1 is between negative infinity until negative 1 over 2. Okay, so substitute x equals to negative 1 into the first and second bracket. So we have negative 2 plus 1 times negative 1 minus 2 is negative 3. So we have here negative 1 times negative 3 give us positive 3. For the second columns, choose any number that between these two numbers. So let's choose x equals to 1. Okay, when x equals to 1, the first bracket we have 1 times 2 plus 1. So 3. And second bracket 1 minus 2. 1 minus 2 is negative 1. So multiply these two numbers, we get negative 3. Next, for the last column, x greater than 2. Okay, let's choose x equals to 3. Okay, substitute into the first bracket. So 3 times 2 is 6 plus 1, 7. Times 3 minus 2 is 1. So we get 7. Now, which columns or which intervals satisfies the inequality? Okay, we know that from this inequality, left hand side is less than 0. Less than 0. Okay, means we need to choose the interval that give us negative value. Okay, negative value. Okay, so which interval that give us negative value? This interval. Therefore, the solution for this inequality is the solutions of the given inequality consists of all real numbers x such that x negative 1 over 2 until 2. Or also can be written as the interval x greater than negative 1 over 2 less than 2. Section 5.2.2 Absolute Inequalities. Let A be any equation and B be any real number. The following are the properties of absolute equation. Okay, for modulus equation equals to b, if and only if equation A equals to b and equation A equals to negative b. Okay, this happened because we already know inside the modulus, the equation can be positive and negative. So we can write the equation as positive A equals to b and negative A equals to b. So this will be A equals to negative b. For the second properties, we have modulus A less than b. Okay, as I mentioned before, equation in a modulus can be positive and negative. So for the positive equation, we have A less than b. But for negative equation, we have negative A less than b. We rearrange this. To eliminate negative from the left hand side, we need to divide both sides by negative. When dividing both sides by negative, we need to reverse the sign. Okay. A greater than negative b. So from here, we can see that A less than b and A greater than b. We can combine these together and it becomes A greater than negative b and less than b. Okay, for the third properties, we do the same as the second property. We have A greater than b and also negative A greater than b. This one is okay, but for this one, eliminate negative from the left hand side by dividing both sides by negative and reverse the sign. Therefore, we have A less than negative b. So we have two regions. If we draw the region, we have negative b and b. So one is A greater than b and another one is A less than b. The area is all that on the left side of b. Therefore, the equation can be from negative infinity to negative b, unite with from b to infinity. Okay, let's discuss example 5.24. We have to solve a equation modulus x minus 5 equals to 3. Okay, as we know, inside the modulus, the equation can be positive, x minus 5, and also can be negative times x minus 5, and equal to 3 for both signs. Okay, solving for x give us, okay, for the positive and this one for negative. So we solve this equation, we get x minus 5 equals to 3, x equals to 3 plus 5, x equals to 8. And for the negative equation, we will get x minus 5 equals to negative 3, x equals to negative 3 plus 5. Therefore, we get x equals to 2. Thus, the given equation has two solutions, x equals to 2 and x equals to 8. Okay, let's move to the next example, 5.25. Now we have absolute inequality. Okay, solve modulus 2x plus 1 less than or equals to 4. Okay, this, the left hand side of the equation of the inequality can be written as positive 2x plus 1 less than or equals to 4, or negative times 2x plus 1 less than or equals to 4. Therefore, okay, so we solve the positive. the positive equation. So we get 2x plus 1 less than or equals to 4. Now to eliminate 1 from the left hand side, we need to subtract 1 from both sides. So therefore, we get 2x less than 4 minus 1. Divide both sides by 2, give us x less than 3 over 2. Okay, this is the solution that we obtain from the positive equation. Now, for the negative equation, we have 2x plus 1 times negative less than or equals to 4. Now, we eliminate negative from left hand side. To do this, we need to divide both sides by negative and reverse the sign. Therefore, we get 2x plus 1 greater than or equals to negative 4. Now eliminate 1 from the left hand side. So we get 2x greater than or equals to negative 4 minus 1. Eliminate 2 from the left hand side, give us x greater than or equals to negative 5 over 2. From here, we can see that the area for this solution is, we have two values. One is negative 5 over 2, another one is 3 over 2. Okay, for the negative, we have x greater than negative 5 over 2. So all x that greater than this number. So the area is on the right side of negative 5 over 2. Then for the second interval, so we have x less than or equal to 3 over 2 here. Okay, and all x that less than this number. So we have all x that on the left side of 3 over 2. Okay, from here we can see that the area that satisfies these two intervals is this. Okay, from negative 5 over 2 until 3 over 2. Therefore, the solution are the real numbers in the interval of x greater than or equals to negative 5 over 2 and less than or equals to 3 over 2. Now for example 5.26, okay, we have to solve this inequality. Okay, we know that inside this modulus, the equation can be positive and also negative. So first we write the positive equation. First we write the positive inequality. We have 2x plus 3 greater than 9. Solve this inequality, give us 2x greater than 9 minus 3, and then x greater than 9 minus 3 is 6 over 2, and therefore x greater than 3. Now for the negative inequality, we have negative times 2x plus 3 greater than 9. Eliminate negative from the left hand side. We need to divide both sides by negative and reverse the sign. Therefore, we get 2x plus 3 less than negative 9. Now, we eliminate 3 and 2 from the left hand side. we do one by one. We have 2x less than negative 9 minus 3 and x less than negative 12 over 2. Therefore, x less than negative 6. So from the number line, okay, we can see the area that satisfies these two inequality. Okay, first we have negative 6 and then 3. Okay, for the first interval, all x that less than negative 6. So we know all x that less than negative 6 on the left hand side of negative 6. And for x greater than 3 is all x that on the right side of 3. Therefore, the solution consists the numbers in interval negative infinity until negative 6, unite with 3 until infinity. Okay, for example 5.27, okay, I would like you to try by your own and do this as your homework. Okay, let's move to the last example in this chapter, example 5.28. Okay, we have a problem. Okay, a certain welding operation must be performed at temperatures between 1800 degrees Celsius and 2200 degrees Celsius. What is the temperature range in degrees Fahrenheit? Okay, given this formula. Okay, this is formula. Okay, how to change Celsius to Fahrenheit. Okay, we are given the temperature. Temperature in Celsius. First, we write the temperature, okay, of the welding operation, okay, in Celsius, okay, from 1800 degree until 2200 degree. Then we change the unit from Celsius to Fahrenheit by using this formula. C is equal to 5/9 times F minus 32, and also in the same range, 1800 degree until 2200 degree. Okay, we want to find the range in Fahrenheit. So let's do one by one. We solve the first interval. Okay, we have 5/9 times F minus 32 greater than or equals to 1800 degree. We only want to have F on the left hand side. So we need to eliminate 5/9 from the left hand side, okay, by multiplying both sides by 9/5. So we have F minus 32 greater than or equal to 9/5 times 1800. Now we have F greater than or equals to 32 plus 9/5 times 1800 degree. Solving this give us F greater than or equals to 3272 degree. Okay, next we solve the second interval. Okay, from this equation to 2200. So we have 5/9 times F minus 32 less than or equals to 2200 degree. Okay, we do the same as the first one. Okay, we have f minus 32 less than or equals to 9 over 5 times 2200 degree, and f less than or equals to 32 plus 9 over 5 times 2200 degree. Calculate this, we get f less than or equals to 3992 degree. Therefore, the temperature range in degree Fahrenheit is from 3272 degree until 3992 degree. That's all. Thank you.